to wear dark shirts. So the example that we're doing is that we have two particles. One is at point A, one is at point B. They have velocities given by VA and VB respectively, and we want to know the time that they collide and the position of the collision. So I'm going to do this in a slightly different way. You can follow the way that's in the notes if you find that's easiest, but there's something that I think is very intuitive, and that is that if these two particles are going to collide, then the time at which it's going to happen has to be equal. Does that make sense? You can't have one colliding after t equals 1 second and the other one colliding at t equals 2 seconds. It's just not possible. So what I'm going to do is I'm going to take these down and I'm going to write them together. So I'm going to have 3, 4 plus, and now I'm going to add the velocity. After some time, 9, minus 2, and I want this to equal this. So I want this to equal 6. I'll show you why I'm writing it underneath now. 6, 7 plus t 6 minus 5. Okay, so I want these two things to be equal. So what I'm going to do is I'm going to subtract these two from each other. So in other words, I'm going to move everything that doesn't involve t to the left-hand side and everything that involves t to the right-hand side. So I'm going to subtract this from this. I'm going to get 3, 3 is equal to t 3, 3. So what you'll notice in this particular case is that in order for this to be a multiple of this, there has to be some t. So for example, if it were, say, t 2, 3, then we'll know that these particles will never collide, because there's no t such that this vector will equal this vector. But here it actually works out quite nicely, and we just get t is equal to 1. This was a very easy one. So yeah, 9 minus 6 is 3, minus 2 plus 5 is 3, so there's our t's. And then here 6 minus 3 is 3, 7 minus 4 is 3. So this is a nice one. And then we just substitute this value into either one of these. So either in here or in here. So the position of the collision is just going to be 3, 4 plus 9 minus 2, which is equal to 12, 2. If you do it in here, it's the same thing. You're going to get 6, 7 plus 6 minus 5. Well, 6 and 6 is 12. 7 minus 5 is 2. So yeah, a very nice problem. But I think in general, t equals 1 is maybe a bit too easy. You'll probably have something like, let's just say, 9, 9, I don't know, then t is equal to 3. So after 3 seconds, this will be the position that they'll collide, or rather, not that will be the position that they'll collide, but this is the time, t will be 3, giving you this time that you'll need to get this, and then you'll substitute that into your equations. But yeah, as I said, I definitely want to do a separate video on the nearest approach, and I think that will be it for vectors. I'll see you in tomorrow's video, and then we'll go on to chapter 2.